Thank you very much for the introduction. Dear colleagues, it's a real honor to present the results of the study to you. Today I'm presenting this abstract on behalf of a large international group of co-authors who made the study possible, and none of us have a conflict of interest with this study results. We all know that congenital heart disease comprises a wide spectrum of heart defects. Some of them are mild and rather benign. Most of our patients have two ventricles, some have one ventricle, and we also know that some of these heart defects really can be nasty. And when we want to investigate the impact of the heart defect on the life and on the outcomes of the patients, then we are quite often confronted with limitations. Limitations in numbers, in terms of patient numbers. Because indeed, some heart defects only occur in a limited number of patients. And therefore, such comparative studies are quite often done on disease complexities. We try to combine patients into groups to make them big enough to do feasible comparative analysis. But as you know, within the complexity groups, we also will find some variability, which is largely undetected right now in terms of the precise outcomes. This is exactly what we wanted to address with a study that I'm presenting today. The goal of the current study was to compare the physical functioning as reported by the patients and the quality of life in different congenital heart defects from a large international sample, because we need a critical mass of patients. This study relied on Approach IS. And Approach IS stands for Assessment of Patterns of Patient-Reported Outcomes in Adults with Congenital Heart Disease International Study. This was a study conducted in the period 2013-2015 in 24 centers from 15 countries in 5 continents. Overall, we included more than 4,000 patients. The sex distribution was rather equal, and the median age was 32 years. Since we only included patients or heart defects where we had at least 50 patients, therefore we could not include all the 4,000 patients from Approach IS in this analysis and limited it to the 3,500 patients for which we had 50 patients or more in each heart disease category. The complexity of the heart defects looked like this. About 1/4 had a mild condition, about half of the patients had a moderately complex condition, and 1/4 had a complex heart defect. Since we looked at patient-reported outcomes, questionnaires is what we use. And we used the physical component summary of the SF-12 to measure physical functioning. And we measured a very straightforward way of quality of life by using a linear analog scale. This is a vertical line ranging from 0 to 100. Worst imaginable quality of life to the best imaginable quality of life. The analysis, statistical analysis, since this is an international study, we needed to do multi-level analysis. And therefore, we used multivariable general linear mixed models. And we know that there are many factors that impact on physical functioning and on quality of life of the patient. So we wanted to adjust for these known patient characteristics, being sex, age, educational level, employment status, marital status. And since we used multi-level analysis, we had country as a random effect. On top of this, in the second phase of the analysis, we added the New York Heart Association class as as a parameter of functional status to see to what extent the explained variance of the heart defect was changing when we put functional status into play. Let's look at physical functioning first. This is the list of heart defects that we included. And patients with coarctation of the aorta reported the highest score of physical functioning of all. Knowing that coarctation is not a mild defect but a moderate defect, it indeed gives a new perspective that we should not only look at mild defects and think that these patients have the best outcomes. At the other side of the spectrum, cyanotic heart disease or Eisenmenger syndrome had the worst effect. We also looked at the distribution of the scores using these ridgeline plots. And this really gives you information that goes beyond the mean scores and standard deviations because it helps you to understand what is the distribution, what is going on over the entire spectrum of answer or response categories. Using the multi-level analysis, we looked at to what extent are the different heart defects statistically different from the heart defect with the highest score, in this case, the coarctation of the aorta. And you see, no surprise, all the complex heart conditions do significantly worse than people with coarctation. But surprisingly, some mild defects, being the repaired ductus arteriosus, ASD and VSD, also scored significantly lower than patients with coarctation. And of course, we should not only look at statistical significance, we also wanted to look at clinical significance. And that's the reason why we investigated or why we calculated the effect sizes. And for both the cyanotic heart disease and people with Marfan, the difference with coarctation was large. For people with congenitally corrected transposition of the great arteries, pulmonary atresia, univentricular heart, that's it. The difference is moderate, and for the other differences, the difference was small or negligible. Overall, the explained variance of the heart defect towards the outcomes was 4.1%. When we were putting New York Heart Association class into play, this explained variance reduced to 0.9%, which kind of indicates that it is rather the functional status of the patients instead of the heart defect itself that plays a role. And as you can see here, only a few of the heart defects remained significantly different from the coarctation, which was the reference. What about quality of life? The same strategy we used here, and people with isolated aortic valve disease had the best score, and consistently people with cyanotic heart disease and Eisenmenger syndrome had the worst score. Also here, the nuanced picture that we have with the ridgeline plots, and indeed you see that people with conduits and people with the Marfan syndrome really have two tops at the lower spectrum of the scores. Congenitally corrected transposition, univentricular heart, cyanotic heart disease, and conduits scored significantly lower than the reference group. And for the cyanotic heart disease, this difference was large. For congenitally corrected transposition, it was a moderate defect. The explained variance was 1.2, and with the New York Heart Association class into consideration, it reduced to 0.4, and none of the significant differences remained. I want to come to the conclusion. With this study, we try to uncover the following. Coarctation of the aorta had the best physical functioning, and isolated aortic valve disease the best quality of life. Cyanotic heart defects and Eisenmenger syndrome had consistently worse outcomes. The explained variance of the type of the heart defect, however, above and beyond patient characteristics were small and even reduced when the New York Heart Association class was put into the equation. And this kind of suggests that the functional impact of a heart defect is probably more determining the outcomes than the heart defect itself. Thank you very much.